In order to connect to my Azure subscription, I need to create what's called a service connection. So you can find that in project settings. Click here. I will be connecting to Azure using the resource manager. So I'll select this radio button and I'll use this service principal automatic. Now, the first time I ran this, I had to sign in with my credentials. Now it shows me my subscriptions available and my resource group. I'm using this one for the course. And then I'll give it a service connection name here. Like that. And then I'll grant access permission to all pipelines. Now I have my connection, and when I go to work with my pipelines, I can tell it to use this when it needs to connect to Azure. We've set up this pipeline so that it is triggered when there's a change to the repository. So that could be a commit, it could be a pull request. It doesn't matter. As soon as there's a change to the repository, it will trigger the build. So to demonstrate that, I'm logged in with Terry's account here. She's opened up this main page, the site, this index.cshtml. She's going to make a change here. So she'll choose edit. Makes a change there. Now over here on the left side of the screen, I've got my account and I'm looking at the runs for the pipeline. Let's see what happens when I click on commit. After about 30 seconds, I see this new link. It says load new run. I click here. And I can see the spinning wheel that is running. So that has kicked off the pipeline. And after about 2 minutes, I will have the update here, and then we'll refresh this home page here to see if there's any new changes. It's been 2 minutes, and now I will refresh the page. That verifies that we've deployed to the Azure App Service. And then I'll click over here. Actually, I don't need that tab open anymore. Click over here and I can see there's my successful run. And there's some details here that this was triggered by Terry adding something to the main branch. No matter how comprehensive a framework, there will always be some features that haven't made it into the shipped product. Systems that provide extension points are valuable because third parties can enhance the ecosystem with their offerings. Microsoft systems are known for their extensibility support. Each of the systems shown here can be enhanced with additional features. This open approach allows other companies and programmers to create tools that add extra functionality to the system. All these Microsoft systems have a marketplace where you can find and install extensions. The same applies to Azure DevOps. Use the marketplace to find and install Microsoft and third-party extensions. The marketplace offers thousands of extensions that can be installed to improve your DevOps workflow. This is a convenient way to add new toolsets to your organization and projects. Development teams can purchase third-party tools, use the free extensions, or create their own. On the marketplace at visualstudio.com, click on the Azure DevOps section and then see some of the more popular and featured extensions here. Scroll down to the bottom of this page, and you can see them categorized by type. Azure Boards, Azure Pipelines, Azure Repos, Azure Test Plans, and more. And then, of course, you can drill down and see all the extensions by clicking on See More. Looks like the day I'm looking at this, there's 318 Azure Board extensions. Another way to extend Azure DevOps is by integrating with your team chat and collaboration software. Microsoft provides DevOps extensions for Slack and Microsoft Teams. Additionally, there are extensions available for Discord, Google Chat, and other platforms. They enable real-time notifications about build statuses, pull requests, and work item updates, facilitating seamless communication within your development team. The Microsoft Teams integration allows you to receive notifications and create work items directly from your chat. For example, let's look at this demo team I have in Slack. Check out the lower left sidebar. You can see we've installed the Azure Boards, Azure Pipelines, and Azure Repos extensions. More details about this will be covered in the next video. Azure DevOps extensions can be categorized into several other types based on their functionality and use cases. Here are some of the key categories. Project management. These tools enhance project management capabilities by providing advanced task tracking, sprint planning, and backlog management. They can integrate with other project management software, allowing for a unified view of project progress and team workload. Extensions in this category provide static code analysis, code quality checks, and linting tools. They help maintain high-quality code by identifying potential issues early in the development process. Examples include SonarQube for comprehensive code analysis and ESLint for JavaScript linting. Custom widgets for dashboards provide visualizations, metrics, and reports that help teams monitor the health and progress of their projects. These widgets can display information like build statuses, work item trends, and code coverage metrics. Extensions offering insights and analytics help teams understand various aspects of the development process, such as build performance, test results, and code coverage. Azure DevOps Analytics provides powerful reporting capabilities and customizable dashboard to track key performance indicators. Tools in the API and connectors category provide connectivity to other platforms and services, such as cloud providers or third-party applications. For example, the Azure DevOps REST API allows you to programmatically interact with Azure DevOps services, enabling custom integrations and automations. Extensions that can scan for security vulnerabilities in code and dependencies help ensure that applications are secure. Tools like White Source Bolt and SNCC can identify vulnerabilities in open source libraries and dependencies. The compliance extensions help ensure compliance with industry standards and regulations by providing features like audit trails, policy enforcement, and reporting. The tools in this category help you integrate with popular integrated development environments like Visual Studio and code editors like Visual Studio Code. They provide features like source control integration, work item tracking, and build management directly within the editor. This is the code review and pull request category. These extensions enhance the code review process and manage pull requests more effectively. They provide features like inline commenting, automatic code review checks, and merge conflict detection. The Azure Repos extension, for example, offers a rich set of tools for managing pull requests and conducting code reviews. Now let's look at service hooks. They help you integrate with external services, enabling automated workflows and notifications. Service hooks can trigger actions in other services, such as sending a message to a Slack channel when a build completes or creating a new issue in GitHub when a work item is updated. You could, for example, automatically create a card in Trello when a work item is created, or send a push notification to your team's mobile devices if a build fails. Service hooks are based on the publisher's subscriber design pattern. In this classic pattern, publishers define a set of events such as build started or build complete. You can create subscriptions for those events in the subscriber applications. In this example, we have Microsoft Office, User Voice, and Azure Storage acting as subscribers. Each subscriber defines the action to take when the event is triggered. For instance, you could add a row to an Excel table or update a feature request on User Voice. If none of the published extensions in the marketplace meet your needs, you can create your own. However, this is beyond the scope of this course. For the rest of this chapter, we'll explore how to integrate with Slack and how to install some marketplace extensions.